Alright, boys and girls, welcome to our fifth and last video lesson in Chapter 8, Applications of Sine, Cosine, and Tangent. Here we go. Okay, what you need to know are two very important terms. Angle of elevation, that is the angle when you are looking up at something. The angle of elevation is always measured to the horizontal line of sight. So if I'm standing right here and I'm looking at this point right up here, this angle right here is my angle of elevation. Notice it's measured from the horizontal. My angle of depression is very similar, okay? And it is the same thing, but this time I'm starting at the top. I'm standing here and I'm looking down at this point right here, and I'm measuring this angle. This is my angle of depression, okay? And that angle, again, is always measured to the horizontal. Please don't measure ever angles of elevation or angles of depression to the vertical. Many kids do that and they get a problem wrong. Don't be one of those kids. Okay? Let's go. No problem. So, we are standing, you are on top of a 500-foot building, and you see a car at an angle of depression of 74 degrees. How far is the car from the building? So we want to know this length right here. Okay, that's my x. I'm standing at the top of a 500-foot building, so that's 500 feet right there. I'm standing right here. Okay, and I'm looking down at the car right here, and I know that my angle of depression is 74. So this angle right here is 74 degrees. Notice that it's not this angle right here. This is not the angle of depression because it's measured to the vertical. We always measure our angle of depression to the horizontal. Okay, so now I can actually just draw an imaginary line right here in blue. And I have a right triangle. You can see my right triangle. I'll just highlight that in red. I have a right triangle right here. I'm looking for that x. I know that this length right here, whoop, that's a 500. I was trying to write with my marshmallow. Okay, so I now know that the sine, I'm sorry, not the sine, the tangent, so I got the opposite leg, is 500 over my x right here. So tangent of 74 is equal to 500 over x. So I'm going to write that now. Tan of 74 is equal to 500 over x. I'm going to multiply both sides by x. So I'm going to get x times tan 74 is equal to 500. I'm now going to divide both sides by tan 74. I'm going to not write that again because I can't. But I know now that x is equal to 500 divided by tan 74. So whip out your calcs. I'll whip out mine. And I do 500 divided by tan 74. Close my parentheses, hit equals. And I got my car is 143.4 feet away from the building. One more. Find the angle of elevation to the peak of a mountain for an observer who is 155 meters from the mountain. If the observer's eye is 1.5 meters above the ground and the mountain is 350 meters tall. So I'm standing right here. Here I am. I'm looking at the top of a mountain. Whoop! There's my mountain. Here's my head. Don't want to miss out on that. And I'm 155 feet. I'm sorry, 155 meters from the base of the mountain. I know that the mountain is 350 feet tall. And I know that I am 1.5. So actually, if I think about it here, not drawn to scale, this height is going to be 350 minus 1.5, which of course is 340. I'll write that again, 348.5. So now I can use my trig. I know that the tan of the angle I'm looking for, because I'm looking for this angle right here, my angle of elevation, tan of x is equal to the opposite, which is 340. I keep doing that. 348.5 over 155. Now this is a little bit different. As opposed to looking for a length, we are looking for the angle. So we're going to use on our calculator the inverse tan, which is the second tan. So I'm going to type in here second tan, and then I do 348.5, 348.5 divided by 155. Close my parentheses, hit equal, and I have an angle of 66 degrees. Okay, so whenever we are looking for the angle, we use the inverse sine function, and whenever we're looking for a length to get the actual tan, we use the regular tan, or just the straight buttons. All right, that's it. We'll see you soon.